Hey everybody, Mr. Murray here, and just talking a little brief introduction here into Chapter 9, Graphing Quadratic Functions. Those are functions with a highest exponent of 2, and when you graph that, you get this curvy kind of shape, and the name of this kind of graph is a parabola. We'll be talking more about, how it's applied to various things, but just a little introduction to vocab today. And so for this graph, let's find each of these things. The y-intercept, that's an old term. That just means where does the graph intersect or intercept the y-axis. So the y-axis is this vertical axis, and where does it hit? At -8. So you could say -8, or if you wanted to answer with an ordered pair, that's 0, -8, right? Any y-intercept, the x-coordinate is 0. Okay, the x-intercepts for the graph, those are right here where the graph hits the x-axis, and there are 2 of them. But you might also see them referred to as the roots of the function or the zeros of the function. So if anybody asks you for the x-intercepts or the roots or the zeros, they all essentially mean the same thing. Where does this graph hit the x-axis? And so there are 2 for a lot of parabolas. And so these ones would be at -2 and +4, or if you answer with an ordered pair, -2, 0, and 4, 0, right? The y-coordinate is always 0 when you're on the x-axis. Okay, now here's some new terminology here. The vertex. The vertex of a parabola is, I would say, the point where the graph turns around. Or the turning point of the graph. So you see you got this curve here, and then it's going down, and then it turns around and starts to go back up. That spot where it turned around is called the vertex. And so that would be right here. It's the lowest point of the graph, the minimum point of the graph. And so that point is at, just be careful, it lines up with +1 for the x value and -9 for the y value. So that would be at 1, -9. Okay, and the last new piece of vocabulary, last new term of this chapter is the axis of symmetry. Now, the axis of symmetry is the line that it's a vertical line that passes through the vertex and splits the graph down the middle. So this vertex was at 1, -9. And you see symmetry means like a mirror image and being the same, being symmetric. If you draw a vertical line right down the middle, right through that vertex, that's where it's going to split the graph into 2 equal halves, and everything is like a reflection across that. Everything's like a mirror image. This whole side reflects onto this side. So that line that goes right down the middle is what we call the axis of symmetry. And it's a vertical line. It's an equation, so all vertical lines are x equals, remember our Hoylux, and in this case, this vertical line is x equals 1. Passes through 1 on the x-axis, it passes through this vertex, so everything's got an x-coordinate of 1. So there's the axis of symmetry. There we go, those are the new terms, and I'll do a second example just so you see it and you feel comfortable with it, hopefully. So here's a different graph. Notice this parabola is a little bit skinnier than the last one, and it's opening downward. It's a big deal. They come in all shapes and sizes, but it's still called a parabola. The y-intercept, where do we hit the y-axis? That would be right here at the origin, or at 0, 0. What about the x-intercepts, or roots, or zeros? One right there, and right here, the 0, 0, and -4. 0. Where's that vertex? Where does that graph turn around? And that would be right here. In this case, it's the maximum point, the highest point of the graph. And that would be at, just look at your x and y coordinates carefully, -2, 8. And your axis of symmetry is that vertical line that goes right down the middle and splits the graph into 2 equal halves. And so since it's passing through this point, the vertical line of x equals, and all the x values are -2 on that vertical line. Okay, so there you go, just a little brief introduction. If you have any questions, see me for help, but have a good day.